to finish off with the polynomials, going to look at a specific type of question. That's how we create new polynomials using the roots of another polynomial. So if you know alpha, beta, gamma, delta, however many roots there are the roots of a particular polynomial, and say you wanted to make a new equation whose roots are the reciprocal of those. So one on alpha, one on beta, and so on. How do you do it? Well, what you do is you sort of force the solution. So you let y equal how the root looks like. Right? Because originally we would say x is the pronumeral in the equation. We want to change it to 1 on x, because instead of alpha, we got 1 on alpha. Instead of beta, we got 1 on beta. Instead of gamma, we got 1 on gamma. So instead of y equals x, we want y equals 1 on x. But what we then do is we rearrange that and make x the subject and then substitute it into the original equation. And that'll come up with a new equation. Now, it might not be a polynomial, so you might have to play around with it to make it a polynomial, but that's the basic idea. So if we had one where we wanted to make the roots a multiple of the original root, so say each root was k times the original root, then I'd let y equal k times x. X would then be y divided by k, substituted into the original polynomial. If I was to add a constant to each root, right, same idea. Okay, I'll let y equal x plus that constant amount I'm adding on, rearrange it, make x the subject, substitute that into the old polynomial. How about the root squared? Okay, we'll let y equal x squared, so to make x the subject there, x would be y to the power of a half, substitute that in. So let's have a look at some examples. So our original cubic is x cubed plus x plus 2 equals 0, and alpha, beta, gamma are the roots of that. We're going to create one. Well, let's have a look at that first type we talked about, where the solutions are the reciprocal of the solutions to the original equation. So I'll let y equal 1 on x, make x the subject, then I'll substitute that into the original polynomial equation. Now, of course, that's not a polynomial, because we've got pronumerals on the bottom of the fraction. Remember our rules for polynomial, the powers have to be positive integers. But that's okay. I can multiply both sides of this equation by y cubed, and that'll get rid of the denominators. So if I do that, I get 1 plus y squared plus 2y cubed, which is a polynomial. So what we should find, if we were to solve these two equations, the solution to this new equation, 1 plus y squared plus 2y cubed, would be the reciprocal of the solutions to the original equation. How about we just add 1 to each of the roots? Okay, so if we add 1 to each of the roots, we'll let y equal x plus 1, rearrange it, make x a subject, substitute it in. Now, I suppose technically that is a polynomial, but let's expand it out to make it look like one. So y minus 1 cubed, y minus 1 and 2, tidy it all up, group like terms, and we get y cubed minus 3y squared plus 4y is equal to 0. The interesting thing here is I now know a solution to the original equation straight away. Y equals 0 is a solution to this equation. Remember, this equation are the roots of the old equation plus 1. So if 0 is a solution to this new equation, then a solution to the old equation must be negative 1. Okay, you can get lucky like that, and that can help you solve equations sometimes. Let's have a look at the one, what we do when we got it squared. There's a little bit of manipulating needed with this one. So we'll let y equal x squared, x will be y to the half. Substitute that in, but of course we now have fractional powers, and polynomials don't have fractional powers. Now you think, oh, fair enough, we'll just square both sides, but the problem is, when we square, we're going to get twice the product. So you're still going to have the fractional power. So before you square, I mean, it's a sensible thing to do. Square it to get rid of that power of a half. But before you do that, what you have to do is isolate the terms. So we've got y to the 3 on 2 plus y to the half plus 2. On one side of the equation, we'll have everything with a fractional power. And on the other side of the equation, we'll put all the terms that don't have a fractional power. Now in this case, that's only the number 2. So I've moved that to the right-hand side. We've got negative 2. I've also factorised the y to the 3 on 2 plus y to the half. Remember, when you factorise, take out the lowest power. So the lowest power is y to the half. Now I can square both sides and get rid of the fractional power. Because when I square both sides, the y to the power of a half becomes y, the y plus 1 becomes y plus 1 squared, and the negative 2, of course, becomes 4. I've now got a polynomial. So, squaring, tidying up, grouping our terms, there it is, y cubed plus 2y squared plus y minus 4. So, the solutions to this equation will be the squares of the solution to the original equation. How about the reciprocal of the squares? Well, it's still just the same idea. I'll let y equal 1 on x squared. So x will be y to the negative a half this time. Substitute in. Again, I've got that problem not only with the fractional powers, but I've got negative powers as well. But I'll do the same thing. I'll put all the powers with the fractions on one side, the 2's going to the other side. How do I fix this negative power? Well, I'll multiply both sides by y to the 3 on 2. Because if I do that, y to the 3 on 2 times y to the minus 3 on 2, or add the powers, you get 0. So that's just 1. But then the other side becomes y to the 3 on 2. So the fractional power basically goes to the other side. Square both sides and tidy it up. So there's our new equation. So same technique every single time, really. It gives us another way of finding alpha squared plus beta squared plus gamma squared. Yes, we could go back to our original equation. And we know it's the sum of the roots 1 at a time squared minus 2 times the sum of the roots 2 at a time turns out to be negative 2. But we've created a new equation that has the solutions alpha squared, beta squared, gamma squared. So really it's just the sum of the roots of that new equation minus b on a. So if I look at that one, so it's back in part C we found that equation, I can say, oh, it's just minus b on a of that new equation, and again it comes up with negative 2. Would I do it that way? Probably wouldn't be my first reaction, but if I had created this new equation, I'd certainly do it that way. That's going to be quicker, just going minus b on a than going the other technique. So I guess it depends what I've already worked out in the problem, whether I'd use that idea or not. Okay, so a couple out of Cambridge, a couple out of Patel. Oh, well, more than a couple out of Patel, isn't it? Quite a few out of Patel.